In this question, we're going to use implicit differentiation to determine the equation of the tangent line to this curve at x equals 1. Well, in order to do that, we're going to first need to find a point and the slope of the line in question. Well, determining a point is pretty straightforward. When x equals 1, we simply sub in an x value of 1 and evaluate y. Well, solving for y tells us that y is 5/2. So the point in question is 1, 5/2. Now we have to figure out the slope of the curve at that point, which will give us the slope of the tangent line. So we're going to find dy dx. Well, using implicit differentiation and differentiating each of these terms with respect to x, we see that the derivative of 15x squared is 30x. Now we're going to subtract, and we're going to figure out what is the derivative of 6xy. We factored out that minus sign, so we're just going to figure out the derivative of 6xy. Well, the derivative of 6x is 6, and the second term is y. We leave that alone in the power rule. Then we're going to add the first, which is 6x in this context, times the derivative of the second. Well, the derivative of y with respect to x is dy dx. I'll call it y prime. Now, distributing that minus sign in, we get 30x minus 6y minus 6xy prime, and that equals 0 because the derivative of 30 with respect to x is 0. We can now isolate y prime, keeping negative 6xy prime on the left-hand side, and adding 6y and subtracting 30x from both sides, we get this as our expression. Isolating y prime means divide both sides by negative 6x, and we have an expression for y prime. We can sub in a y value of 5/2 and an x value of 1, and we see that at the point in question, the slope is 5/2. We now can say that y equals mx plus b. We've got a slope of 5/2 and a point of 5/2 comma 1. So subbing in those numbers gives us a b value of 0, and we can say that the tangent line in question is y equals 5/2 x.